Hey, so in the previous tutorial we started by creating HTML, CSS and JavaScript code for this configurator. We created these inputs and we made this Rete script step by step, we build it out. And in this tutorial we will do the same exact script, but then we will be using Blockly. So let's get started and let's run Blockly. So we are here now. First thing we'll do is go into this old script and we will get rid of this inline script. This will have to come from Blockly this time. So let's remove it and let's wait till we have something to add here. And let's get back to Blockly and I'll close this Rete script for now. Okay, so let's get started. Let's go ahead and create some variables, right? So we already know that we have width, we have length, we have height, and we have thickness of the table. So you may come up with more, of course, things that you want to configure, right? Like color maybe, but yeah, for now, we just want to concentrate on these simple parameters. And what I will do is I will create a function, do something, and I'll call it setup inputs. So what we need to do is we want to set the width to runner input value called width, right? We will do the same for all of the variables that we've set up. So length, let's type in length, let's use height, and let's type a height in here, and let's assign thickness to thickness that comes from the runner input value. So you really have to be careful about these input names. This is all case sensitive and you have to be aware of that. Otherwise the values will not be passed correctly and you will not be able to get it working. Okay, so another thing that we do, you remember in the cube example that we've built, is we say that if there is no width, so we go to logic, we find this not component. So if there's no width, then we will also set it to something. So let's set it to math. Let's say to 1, right? So default will be 1. So whenever we're in Blockly environment, then it will be 1. This will be picked up and this will be undefined. But when we will be exporting script to your own website, right, then this value will be picked up and this will be ignored. And this is what this if statement does. So let's go ahead and do this for all of the values that we have. Oops, yeah, like that. So we have length. Let's do length. So length will be also 1, for example. Let's do thickness. Oh no, let's go height. So height, and let's do height for 0.5, and thickness will be 0.05. Okay, so now we have this function set up. Now we can use this function. So this is a function definition. That's how you should think about it. And we can then call this function by including this component into the script. So this is it. Now we have the input set up and now we can build our code further. And the first thing we will do, as we did with Rete editor, we included some environmental properties to the scene. So let's go into the scene. Let's go into the environment and we will say that we want to enable a skybox of clear sky. So if we run this code now, it doesn't do much, but it does create this 3D skybox and this looks quite nice. So let's go back into the code. We also want to create a directional light, draw directional light, and let's use intensity, that is 3, and the shadow map size, it's fine. I mean, if you want to really increase the shadow quality, you can increase this number, but for us it will be okay. And now we have the environment set up, and we'll start by defining some crucial variables that will be needed to construct this table. It will work a little bit different than we did in Rete, but the idea is quite similar. And let's create a variable called leg height. Let's create it. Let's set it to whatever comes from the height property, but then we will use the math component. So to do the operations that we did in Rete, we need to subtract, and we'll use variable height like this, and we will also use the variable thickness. So height minus thickness of the table will give us the leg height. Another thing that we need is we want to create a variable called a half leg height. This will just give us some values that we can reuse from time to time. So let's use the same component by copy pasting it. Let's use the variable leg height, and let's get rid of that one. Let's see that we want to divide, and let's go into the math. Let's use this component. Let's make it 2. So half leg height will be leg height divided by 2, right? And then we can just use this variable wherever we need that. Okay, so this time we will be moving each leg individually to its correct position, and that's why we need a few more variables. So let's make one for width offset. So let's create it. So let's create this like that, and then we will also use the math category. We'll say that we want to divide the width variable by 2, and we'll include it in the other operation that will subtract it from thickness divided by 2. So I'll pick this like that. Or no, this one is better. So let's use this one. Let's say that we divide thickness by 2, and let's subtract it like this. So this will be a distance from, the center point to the leg, and this is quite important. So this is why this mathematics is needed. And if you don't really get it, just try to wait till you see some visible results of this whole algorithm. And we will do the same for length offset. So let's do that. Let's go ahead here and let's say that we want to create variable length offset. Create. And do this like that. So let's use length. And that's also divided by 2. And then minus thickness divided by 2. So half of the thickness is very important here to get right. Another thing that we will need is we will create the leg itself, right? So we did that also in Rete editor, and we'll just now say that we have leg shape, create, set leg shape, and we'll go into the OpenCascade shapes, solid, primitives. This time we will use a box. Okay. So the width of the leg will be a thickness. You remember that, I guess, from the Rete. So let's find the thickness here. The length will also be thickness, and the height will be the leg height that we've computed here. So let's find that out here. Leg height, and that's it. Now we have our leg shape. It's not visible because it's not drawn yet, but we will do that later. So in order to simplify this, maybe it's okay to say that we also have a variable called thickness divided by 2. So half thickness. Let's create that. Half thickness. Great, because we use that in a few places or along the code base. So this is maybe helpful. And we will not need to use that many components like this. So let's now say that we will use half thickness here and here. So now we will also go ahead and create a variable called compound shape. create, set compound shape to, and we will be using OCCT shapes compound create this component to create the compound shape. And this component expects us to provide a list of shapes as an input. So let's go ahead into the lists component. Let's create the list with these items. And let's just start out with the first item in the list, and that will be our tabletop. And tabletop will be a box. So primitive, create box again. And as in Rete, we will use the width as the width. So let's go into our variables. Let's find the width. Where is it? Here. Let's use the length for the length. And let's use the thickness for the tabletop height. So this is quite important. And so the Y will be also math. It will do. So we will be subtracting variable height by half a thickness. So let's go here. Let's find that. So we have the compound shape now that is including only one shape of a box, and we will be just drawing it now. So let's create a variable called table. This will be the final result of our operations. So let's set the table to a draw async component output. We also need to use a wait component on this draw any async, just so that we get the actual mesh to be given as a result from these computations. And let's use the compound shape for now. So let's find the variable here and let's hit run. So finally we've got some visible result, right? Maybe we should also, for the time being, just draw a grid here so that we see better what happens. Okay, so this looks quite okay, I think. Let's then go ahead and change the height here to 1 meter, for example. Let's run this code again. Yeah, the table just got a bit higher. I think it's working correctly, so let's go back. Let's type 0.5 and let's leave it like that. So now we have our top of the table, and let's now increase the list items in this list by clicking the setting button and dragging this into the list. So now we have another item to be added, and this will be transformed leg shape that we've created here. So we have this initial leg shape. It's in the middle of our table. It's not visible because it's not drawn. We can draw it for now, so let's do that. Let's go here and let's find the leg shape here. Let's draw it now. So you see that we have a leg that's standing in the middle, and it just needs to be positioned in a different location, basically 4 times. So we'll do the transformations for each leg separately. That means that we will need 4 list items, and I'll add more like this. So now we have tabletop and then inputs for all of the legs. I'll go into OpenCascade category. I'll find transforms on shape, and then I'll find the translation. So let's translate the shape. We'll use the original leg shape variable like this. So let's use that here. And now we will use, so let's use half height for Y. So we will move it up, right? So for X we'll use width offset. And for Z we will use length offset. So let's do that. Let's add it like this. And now we can go and just copy this component like this 4 times. Okay. Now if you would run this, you will see that the leg is just on one corner, right? Actually, there are 4 legs now, all in the same corner, and that's because we used exactly the same coordinate to all of them. What we want to do is use a math operation that will negate this. So let's use it like this. So in this case, we'll see that the width is minus. In this case, we'll see that the length is minus, so length offset. Let's do it like that. And then in this last case, we'll see that both width and length are minus. And I'll say that this goes to the removal like that. And now if I hit run, we see a good table output. And this is quite nice, right? The only thing that we maybe want to also add into this compound shape is the ground. So let's do that. Let's add just one more item. And let's hit the settings button again. And let's find the circle face that exists here. Shapes, face, primitives, create circle face. Let's do it like that. Let's see that the radius will be 3. Let's hit run again. Well, I guess, 2 is also fine. This is just smaller radius. And voila, we have quite a good looking model. We did use some options in the previous tutorial, so let's do that here as well. Let's find those simple options for OpenCascade shape. Let's change the color to something more like blue. And let's hit run. And also the width of the table should be like that for edges. Okay, so we're almost finished, right? The last thing that we need to do is actually return this table value to the runner. So let's say that we have here a runner result value, and we'll see that it's called table. And we will also provide a variable called table from the list. So this script is now ready. I will just remove the grid and I will move it a little bit further. In this case, we used a function, right? That's quite nice. You can use functions in Blockly. You can use variables. That's very expressive. And you see that the logic looks a bit more readable maybe than in Rete even, because we were able to define some in-between variables that were computed from these inputs. And we just made this algorithm in a quite an efficient way. So let's now hit export to runner. Let's minify this. Let's copy it. And let's see if it works. So I'll just go ahead here in this inline script. I'll hit paste. And voila, we have our table. Now the question is if we did all the things correctly. So let's see if the width adapts nicely. Yeah, that's fine. The length is also changing the length. The height, yeah, it does work, right? And the thickness is just working also as expected. I'm not gonna go into detail how this HTML works in the JavaScript itself. We did that in the previous tutorial where we used Rete. If you're interested in that, check it out there. We use these models and everything, and I was explaining it there. I hope you enjoyed this tutorial, and in the next one we will be using TypeScript to just code exactly the same table, and I hope to see you guys then. Cheers guys, bye.